Hello everyone, today we're going to be working on example 4-2, and this example is asking us to determine the resultant moment of the four forces acting on the rod about point O. So as you can see, here are four forces: the 50 newtons, the 60 newtons, the 40 newtons, and the 20 newtons. And we're going to try to determine the resultant moment acting on the rod about point O, which is right here. So before starting this problem, I just want to remind you guys that the convention of for the moment is that the convention is usually that counterclockwise is positive, and this is how we show it, that counterclockwise is positive. And also remember that moment is equal to the force times the distance. So now we could take a look at our four forces that we have here. And as you could see, we have some vertical forces, the 50 newtons and the 40 newtons. And then we have some horizontal forces, which is the 60 newtons and the 20 newtons. Now, for our vertical forces, what we have to do to determine the moment around that point O is we have to take our vertical forces and we have to shift them so that they align to this y-axis where point O is sitting on. So for this 50 newtons and this 40 newtons, we're going to shift that over here so they could align to that y-axis. But then for our horizontal forces, what we have to do is we have to shift them upwards or downwards, depending on where they're located, so that they could align to the x-axis. So we can now proceed to solve for the resultant moment. So our resultant moment about point O. So we're going to start off by saying that counterclockwise is positive, like we mentioned earlier, and that now we know that our resultant moment about point O is equal to, we're going to start off with our 50 newtons. Like I mentioned earlier, this is a vertical force, so we're going to have to shift that to our y-axis. So remember, moment is equal to force times distance. So here we have our force. Now we need the distance. And as you could tell, from the force to the y-axis, we have 2 meters. So that's our distance. Now, since we're moving to the left, that's going to be negative because once again, remember, anything going to the left is negative, anything going to the right is positive. So that's why that's going to be negative. So we have negative, since we said that we're shifting that to the left, is equal negative times we have our force, 50 newtons, times distance, which we know that's the 2 meters. Now we're going to proceed to the next force. We have our 60 newtons, which is a vertical force, but as you could see, sorry, not a vertical force, a horizontal force. But as you could see, this horizontal force is already sitting on this x-axis right here. So in a way, we don't really have to do anything to it. That will simply just be zero. But if you guys want to write it out, just to include it in your steps, this is how you would do it. You would just write out plus, once again, our force, 60 newtons, times the distance, and this is where that distance will equal zero. So 0 meters. And as you can see, that will just simplify to equaling zero because we don't have to shift that up or down. Now we're going to proceed to our 20 newtons. And since this is once again a horizontal force, we're going to shift that so it could lie right on the x-axis. So we have to figure out this distance right here. So we are shifting this upwards. So remember, anything going up is positive, anything going down is negative, which is why it's going to be a positive. Our force is 20 newtons. Now we have to find our distance. As you can see, the distance right here is not given to us. But what is given to us is that this angle right here is 30 newtons, and this side of the pipe is 3 meters. So if we were to take a look at this as a triangle right here, we know that this angle right here is 30 degrees, and we know that this side is 3 meters long. So we're trying to find this side of the triangle. So with correspondence to this angle right here, this is the opposite side of that angle, and we know the hypotenuse side with correspondence to that angle, which is why we're going to times this 3 meters times the sine of 30 degrees, because sine is opposite over hypotenuse. And that will give us the distance that we need right here. So from there, we're going to move on. And so we have our force, 20 newtons, times our distance. And we know that our distance is equal to 3 times sine of 30 degrees. Okay. Now the next thing here. So you guys don't get mixed up. We're going to do these parentheses in blue. And then those ones, yeah, in black. We'll leave those in black. Now we're going to move on to our 40 newtons. Once again, our 40 newtons are vertical this time. So this time we're going to be shifting it to the left so that it could align with this y axis. So since it's going to be shifted to the left, that's going to be a negative. So we have negative 40 newtons. So it's going to be negative. We know that our force is 40 newtons. Now we have to multiply that by the distance. As you can see, it's given to us that from here to here is 4 meters. Since we have 2 meters here and 2 meters here, we know that this is a total of 4 meters. But now we're missing this side. Since our 40 newtons is right here, we are missing this side. We don't know how long that is. So if we were to once again look at that triangle that we drew earlier on, with correspondence to this 30-degree angle, we are now trying to find the adjacent side of that triangle. And once again, we know that hypotenuse side of that triangle, which is why this time we're going to be multiplying 3 times the cosine of 30 degrees, since cosine is equal to adjacent over hypotenuse. But remember, to this number that we get right here, we have to add that to the 4 meters. So it's going to be 4 meters plus that. That's going to equal our distance. So once again, we're going to come over here. We're going to do our 4 meters plus 3 times cosine of 30 degrees. And once we input that into our calculator, and now that we have all of that, we can now input this into our calculator, and we get that the resultant moment around point O is equal to negative 334 newtons meters counterclockwise. But since we're trying to deal with positive numbers, we could rewrite that to saying that the resultant moment around point O is equal to positive 334 Newton meters clockwise. And just like that, we were able to determine the resultant moment of those 4 forces acting on the rod about point O.